Hello, everyone. First of all, I would like to introduce myself. My name is Dianing Novi Tandomala Putri, but you can call me Novi. And I am now working as a junior lecturer in Trisakti University. And today we will discuss about the floating photovoltaic in Kota Tua, Jakarta, Indonesia. So here's our background. Here's our outlines. First we will talk about the background, and then we talk about the objective, and then the floating PV, the result and discussion, and also the summary and also the conclusion. So if we talk about the global emission, which now is become one of the biggest issues in the world, there are lots of countries are agree to reduce the emission, and as a part of the action, this also become one of the reason why Indonesia has a goal to reach 23% of renewable energy share in 2025. And however, up to now, the renewable energy in Indonesia, the application is about less than 5% of the whole total potential in the renewable energy potency in Indonesia. The slow developing of renewable energy, it's because of some problems, of course, and some of it is like, for example, about the problem about the land, and also the high investment, and also it need more information, more research in order to make a good decision in Indonesia to apply the renewable energy, especially in our society. And if we talk about the Jakarta, it's one of the capital it's the capital in Indonesia, and it's become a tourist attraction, and it might become the face of Indonesia. So it might represent our society and also our condition. Therefore, our objective is to investigate the floating photovoltaic in Kota Tua, Jakarta, Indonesia, increase the research on alternative energy resources and the use of surface water as land for solar panels, and it also expected as a reference for the KI Jakarta provincial government in implementation of floating photovoltaic in Kota Tua, Jakarta. So it's a very simple for this research. We do a simple step by just start with the literature study, and then we study for the floating photovoltaic, the city, the implementation, and then we do the survey location because we need to collect the data where we want to install the floating photovoltaic if it's possible, and then we do the simulation with helioscope to see how much floating PV that can be installed in this specific Kota Tua area. In all the river, in the water in the Kota Tua area. So basically, floating PV system has has several types, like based on it's the classification based on the PV model tracking and based on the type of floating system used. Actually, this depends on the system designer and several aspects what kind of system that we want to choose. Okay, why we should consider the floating photovoltaic? Because the first one is no land occupancy. So it doesn't need land. If we have our line is full with buildings, we can consider to use the floating photovoltaic, and it also reduces the evaporation, reduce algae, and it's very good to cooling because it's directly above the water. And the infrastructure, it's not a fixed infrastructure when you can just move it or you can just change, or it's easier than the fixed infrastructure in the land. And also the reflectivity increase the incident radiation, which can affect the performance of the photovoltaic. So here is the first step we are focusing in Kota Tua, Jakarta. As we might know that Kota Tua is the first area of settlement in Jakarta, and it starts from Sunda Kelapa Harbor to Pecinan. There's also implementation of low emission zone in this specific Kota Tua area. It's also one of the government way to reduce the emission and become the sample of the city. And Kota Tua has latitude of means 6.13 and also the longitude 106.8. From this data, we can see how much the daily radiation in the city, and it is about more than 5 kilowatt hour per meter square per day, and the clearness index is about 0.6. So what we do here is we divide it into 3 sections or 3 areas in order for us to easier to do the simulation, because it's a very huge area. So we need to make it smaller to easier for us. So here we divide it into 3 areas. So we start the simulation one by one, and slowly we put the PV along the river inside this area. So this red area, we draw the line is the Kota Tua area, and then we divide it into 3 areas, and then we do the simulation. So here is, like, for example, this is for area A, where we also do the shading simulation. So if there is a tree, then we will make the tree. So there is a shading simulation. If you see here, this shading, it will remove the PV. It means that when there is shading, it will decrease the PV. So we are not supposed to install a PV. It's automatically reduced. We won't install the PV under the shading. Here's for the area B. It's also the same. We create based on the environment, and we put the PV inside the river. And here's C area, also the same. We create the shape depend on the river, so we can know how much exactly photovoltaic that can be installed in this specific area. So here are our result and discussion. From the simulation, we get that the annual production is about 11.27 gigawatt hour, and total floating photovoltaic that can be installed is about 8.5 megawatt with tilt angle about 10 degree. And the monthly production here, we can see that it's started from above 750,000 until about from January to December, it's fluctuating, and the highest is above 1,000 kilowatt hour, 1,000. And the other result is some system losses, where from this system there will be losses. There are shading, reflection, inverters, wiring and mismatch, and temperature. And it range from 3.8 to 4.0%. And if we calculate all the losses, it reach up to more than a little bit more than 10% of losses. So here our summary and conclusion. Based on the study, it shows that in this area, it shows that there are potency of 8.4 megawatt photovoltaic that can be installed with annual production of 11.27 gigawatt hour. However, this is a very early analysis, is a very early simulation, so more deep analysis should be done in this system design. That's all for my presentation today. Thank you.